Okay, you're welcome to another physics class. My name still remains Mr. Moses, your physics teacher. In this topic or this week, we'll be looking at first the specific heat capacity by electrical method. This talks about the production of heat from electrical power which involves current and voltage passing through a conductor. In this case, the conductor is a metal that is coiled. So when electricity is passed through a coiled metal, just like you see in the picture of an electric heater or a water heater, when current and voltage is passed through it, it produces heat, which in turn is used to heat different substances. In this case, the electric or water heater is used to heat water. The specific heat capacity of this electrical method can be represented as mathematically as the product of the current, voltage, and the time being the time or the period through which electricity was passed through the metal, divided by the product of the mass and the change in temperature, where I represents current, V for voltage, T time, M the mass. So here's another example of the electric kettle. Inside the electric kettle is a heating element or metal that is coiled. When it is plugged to electricity, current and voltage passes through it. As it passes through it, heat is produced from that metal, hence the water in the kettle is heated. And then from there we go to latent heat. We say latent heat is the heat which causes a change in state of matter without a change in temperature. When we say change in state of matter, we are talking of solid, liquid, and gas. So it's either it's changing from solid to liquid or from liquid to gas, or the other way around. What latent heat is that when, let's talk about liquid, as you can see in the diagram, when a solid is heated to liquid form, at that point of melting, the temperature of the liquid is constant. It stays at the melting point. The temperature does not increase, but there is an amount of heat that causes it to melt from solid to liquid. That heat is called latent heat. Even when you are melting ice, for instance, once the ice gets to melting point, which is 0 degrees Celsius, as it is melting from solid, that is ice block, to liquid, the temperature of that ice and water stays at 0 degrees Celsius, but there is an amount of heat that is absorbed by the ice that converts it from solid to liquid. That heat is called latent heat. It also occurs for boiling a substance. When the substance changes from liquid state to vapor state, it stays at a constant temperature. Water, for instance, is at 100 degrees Celsius when it is changing from liquid to vapor. It stays at 100 degrees Celsius, it does not increase, but there is a particular heat or amount of heat that converts it from liquid to vapor. That heat is called latent heat. It can be represented mathematically as the quantity of heat divided by the mass of the substance. The quantity of heat supplied divided by the mass of the substance, as you can see above. So latent heat, basically, it cannot be measured by a thermometer. It's also known as invisible heat. And then we go to latent heat of fusion. Latent heat of fusion is the quantity of heat required to convert a substance from its solid state to its liquid state without a change in temperature, just as we have said. So when we talk of latent heat, there are two types. First, we have latent heat of fusion. This one talks about the solid to liquid interface, the heat that is absorbed by the solid that converts it to liquid at constant temperature. And then we also have specific latent heat of fusion. Specific latent heat of fusion talks about the quantity of heat that is required to convert a unit mass of a substance from its solid to its liquid state. A unit mass, that means about 1 kg of the mass of the substance converted from solid to liquid state. Once again, we have the example of the ice block, that the heat absorbed by the block that converts it to liquid without a change in temperature, where the temperature remains constant. That's what we refer to as the latent heat of fusion. So latent heat of fusion has to do with heat absorbed that changes solid to liquid. And then we have the latent heat of vaporization. Latent heat of vaporization. This is the quantity of heat required to convert a substance from its liquid state to its vapor state. In other words, while fusion or latent heat of fusion deals with solid to liquid, latent heat of vaporization deals with liquid to solid. That means when the liquid gets to boiling point, it begins to vaporize. It stays at its normal temperature, its boiling point temperature, and the temperature remains constant, but it absorbs heat that cannot be read on the thermometer, which converts it from liquid to vapor. That heat is known as latent heat of vaporization. Taking water, for instance, when you boil water and the temperature increases, when it gets to 100 degrees Celsius, which is the boiling point of water, the temperature of water stays at 100 degrees Celsius while the water is converted from liquid to vapor. The heat that is absorbed by water that converts it from liquid to vapor is what is known as latent heat of vaporization. Latent heat of vaporization, just as you can see above. And then here you can see a graph showing you the points where latent heat comes to play. When the temperature is constant, that's when ice melts to liquid. That's when latent heat of fusion takes place at constant temperature. When the temperature is constant up above, that's when water turns to vapor. But when it is constant, that is when latent heat of vaporization takes place. We should also know that latent heat does not just deal with absorbing heat that changes solid to liquid or absorbing heat that changes liquid to vapor. It also deals with releasing of heat that changes vapor to liquid and the release of heat that changes liquid to solid. So when it is going from solid to liquid or liquid to vapor, it absorbs latent heat. When it is going from vapor to liquid and liquid to solid, it releases latent heat. All is done at the same constant temperature. Thank you for watching. I hope you understand what you have learned. Please go through the text and the questions. We'll discuss more in class. Thank you.